In this video, we will learn how to represent a set of number on a number line using different notation. You may be familiar with inequality notation. Set builder notation is a little bit more advanced. Interval notations, you may have seen this before. We will be using this notation very often in this class. So let's go over how to use these notation. I want to talk about interval notation first. To represent the interval notation, interval is like it has a starting point and an ending point and everything that's in between. So interval notations are usually written like this in this form. You either have a parenthesis or a bracket, and then you have a starting value, and then a comma, and then an ending value. If that interval contains the starting value or does not contain the starting value, then you will use a parenthesis. If it does, then you would use a bracket. So the parenthesis represents open, excluding that value next to it. The bracket represents a closed interval or at the closed ending point or a starting point if it's next to the starting value. It represents include the value next to that. All right, so now let's look at sets of value on a number line and represent them using these notation. All right, so the first one, we have a set of values that contains the 2 and every number less than 2. Using inequality notation, which is going to say those values are x and they are less than or equal to 2. Simple, right? Next, we have the set builder notation. Set builder notation is very similar to inequality notation. The only difference is that we're going to write out the set notation, and then we write x such that x is less than or equal to 2, and then close the set. So notice that this part is pretty much the same. Using the interval notations, if we look at this number line, these values have values that are all the way towards the left side. We're going to call that negative infinity. And then it stops at positive 2. So parenthesis 2. And because it's closed at 2, it contains the number 2, we're going to use a bracket for that. We always use parenthesis next to infinity or negative infinity. Next, we have this interval starting at -1 or greater than -1, but less than or equal to 4. So using inequality notation, x is greater than -1, not equal to because of that open circle, and less than or equal to 4. Using set builder notation is very similar to the inequality notation. Again, the only difference is that we're going to use the set x such that, and then we copy down the inequality notation, -1 less than x less than or equal to 4, and then close the set. Using interval notation, the interval starts at right after -1 and then stops at 4. So the starting value is -1 and then the ending value is 4. The starting value is not included in the interval, so we can use the parenthesis, and the ending value is included. Number 4 is closed right here, so we're going to use a bracket. Next, we have two intervals. First, we need to describe this interval. That interval starts from -5. So the value x is greater than or equal to -5, but less than -2. Or you can read this one as -5 is less than or equal to x less than -2. Using set builder notation, again, we're going to use the set symbol x such that, and then we're going to copy this part over here. -5 less than or equal to x less than -2, and then close bracket. Close braces. For interval, we see two intervals here, so we're going to use two intervals to represent these sets. First interval starts at -5 and then ends at -2. At -5, there is a closed circle, so we're going to use a bracket right next to the -5. At -2, there's an open circle, so we're going to use a parenthesis. Now, because there are two intervals, we will use a union to unite those two intervals together. The second interval starts at +1, and it keeps on going to infinity. At 1, there is a closed circle, so we're going to use a bracket next to 1, and then we always use parenthesis next to infinity. In this lesson, we will learn how to find domain and range. Most often, we will be using the interval notations. Something to look for when we find domain and range is fraction. So just make sure that fractions cannot be 0. So there are restrictions when finding domain. Okay, so first, denominator cannot be 0. And the second, inside, under, oh, let's just say under, even roots has to be greater than or equal to 0. It cannot be negative. We can't have a square root of a -4, for say, because that would not give us a real number.